Hello, I thought I'd do a video to explain how to use cast diagrams or trig graphs to solve trig equations like the one we've got here. This is from exercise 10E in the Pure 1 textbook, question 2D. The way I usually solve these is the way I was taught when I was in sixth form college, which was to use the cast diagram. There are other methods. I'll explain how to use the graph in a minute, which is probably the simplest method. But also there's general solutions. General solutions are probably a quicker way of solving equations like this, but I find that sometimes students forget the general solutions or get them mixed up. So I prefer to use the cast method, but you can just take a pick. Any method is fine. So the way I would do this question, well, before we do the question, just explain briefly how the cast method works. If you look at this diagram here, this is the cast diagram, and I'm just writing down the angles here, so that's 0 or 360. Now if you look at the sine graph is positive between 0 and 90 over here. So if I just highlight this here, so between 0 and 90 the sine graph is positive. In fact that all the sine, the cos and the tan graph are positive in that area there. So on the cast diagram you have an A for all, because a sine, cos and tan are all positive between 0 and 90. Now if we have a look between 90 and 180, again you can see that sine is positive. Okay, so between 90 and 180 sine is positive. So I'll just put an S for sine is positive. As we carry on going, you can see that between 180 and 270, if you can't see this very well, this is 90, this is 180, this is 270, this is 360. So between 180 and 270, which is this region down here, you can see that sine is negative. Okay, so sine will be negative down here, and also over here sine will be negative between 270 and 360. So sine is negative here, sine is negative, sine is negative down here. The idea behind cast diagram is you'll see why it's called cast in a minute if you've not seen it before, but the idea is you just write down in each quadrant which of the trig ratios are positive. Okay, so if we now go and have a look at, if I just rub this off and we go and have a look at the so if we go and have a look at the cos diagram next, so the cos diagram looks like this. You can see that cos is, as I said, that sine, cos and tan will all be positive between 0 and 90, but between 90 and 270, that's here and here, cos is negative. So the only other time that cos is positive is over here, okay, which is between 270 and 360. So cos is positive over here. Okay, so cos is positive between 270 and 360. Now sine, if we look at the sine graph, hopefully you already know what these graphs look like. If you don't, let's have a look at the sine graph here. Sorry, the tan graph. the tan graph will be positive between 0 and 90 here, not positive between 90 and 180, but it is positive between 180 and 270. So tan is positive down here. So that means that, well, you can see why it's called cast now as C, going around this way, C-A-S-T, cast. So we can now use this diagram to solve equations like the one above. So if you look at the equation we've got to solve up here, the question in the book, you can see that sine has to be negative. Okay, so that means that it's going to be down here and down here in this quadrant. We're going to be using those two quadrants later on, because in this quadrant sine is positive, this quadrant they're all positive, this quadrant only cos is positive, and this quadrant only tan is positive. So the two quadrants where sine is negative are these two down here that I've already circled. Okay, so if we go back to the question then and do what we normally do for solving trig equations, if we do, oh, actually, sorry, before we carry on, I think it's always a good idea for these questions to change the range first. Now, if this was just a theta here, we wouldn't need to change the range because the range would already be in terms of theta. But you can see that this here, we need to kind of treat this as one thing altogether, theta minus 10, until the very end of the question. So for our range over here, the range we've given in the question is the range for theta. Now when we use the cast diagram in a minute, we're going to be finding values for theta minus 10. Okay, so if we take 10 away from theta, we've also got to take 10 away from 360 and 10 away from 0, which will be minus 10. Okay, so this is our new range between minus 10 degrees and 350 degrees. So if we use our calculator, do inverse sine on our calculator of minus root 3 over 2. Make sure you're in degrees mode. Make sure there's a small d at the top of your calculator screen, and then you will hopefully get minus 60 for this. Okay, so that means theta minus 10 degrees equals minus 60. Now the value you get on your calculator is called the principal value. Principal value, the value you get on your calculator. Now we need to use that value to find all the other values in our range. Whatever you do not add 10 now. You only add 10 once you've used the cast diagram and found all the other values in the range up here. So do not add 10 till the very end. What we want to do now is use the cast diagram to find some more values. So we've got minus 60 here. Okay, so if I draw on the cast diagram minus 60, this is 0. So if we were going to draw an angle of plus 60, it would be over here somewhere. But because it's minus 60, we're going to go down here. Okay, so we could just write 60 degrees here. Now, where else are we going to draw a line? Well, we've already decided that we want a line down here where sine is negative, because sine is negative. And we want a line down here because that's the other place where sine will be negative. Okay, so you just reflect. That wasn't a very good drawing, really, but you're gonna reflect it in well, it's not really a y-axis, but if you think of it as the y-axis here, you're going to also have an angle of 60 degrees over here. Okay, so now all you do now is you find, once you've drawn your two lines, that's the key really. If you get these two lines in the right quadrants, you can't really go wrong now. You just start at 0 and go all the way around and write down all the angles you've got. So this angle is 180 plus 60, so it's 180 plus 60. So that is going to be an angle of 240 degrees. So if I do these in a different color, so I've got 240 degrees from the cast diagram. Then, oh, where's my line gone? Then we want to do the same, go all the way around, but this time go and find another value. So we keep going around until we hit these lines. So that will be an angle of 360 minus 60, which is 300. Now if you wanted to, we could carry on going around, all the way around again, all the way around again, oops, sorry, and go to there. And we could keep going around as much as we want. But if you look at the range we've got over here, if you look at the range we're given in the box over here, we don't want any values more than 350 degrees, so we can stop at this one here. Okay, if we wanted negative values, we'd have minus 60. We would go around this way, so we'd have minus 60. We would have minus 120, and so on. But we don't want any negative values because, well, we would have wanted a negative value between 0 and minus 10, but there isn't one. So we don't want minus 60. We don't want minus 120. Okay, so now we found all our values in the range using the cast diagram. Only now, right at the very, very end, do you add 10. So theta, these are all the values for theta minus 10. Theta is going to equal minus 50. We're adding 10 to all of these values, by the way, so we're adding 10. Minus 50, although that's not in our range, so we don't really care about that one. Don't leave that in your final answers. If we add 10 to that, we'll get 250 degrees, and add 10 to that, we get 310 degrees. So those are our two answers. Now that took quite a while because I was doing a lot of explanations, but hopefully once you get used to doing this, you'll be able to do this much quicker, and you'll remember it for the future.